lesson is very intense on vocabulary. So after you have a vocabulary word written down in your notes, you're also going to want to transfer those onto your note cards and study them. The first vocabulary word we're going to learn is called a median. A median exists in a triangle, and it's going to connect a vertex of a triangle to the opposite side, that means across from, at the opposite side's midpoint. So if you look at the picture here, we have BD, segment BD. It's connecting to the vertex B to the opposite side at D. And because it's a median, D is the middle point or the midpoint of segment AC. So in this picture to the right, AD and DC are congruent, and D is the midpoint of AC. An altitude. An altitude exists in a triangle and starts at the triangle's vertex, connected to the opposite side of that vertex at a right angle. So looking at the picture, we have BD that is perpendicular to AC, and because it starts here at B, the vertex of the triangle, to the opposite side at a right angle. Okay, in order to use our new definitions, we're going to have to mark our pictures as they're given to us. So it says mark each segment or angle based on the information provided below, and then to indicate what you marked. So the first statement says that AE is the median of triangle ABC. So remember, a median starts at a vertex to the opposite side at the opposite side's midpoint. So that means that E is the midpoint. And what we would mark on this triangle is that because E is the midpoint, BE is congruent to EC. So we put our little hash marks on BE and EC. And then write down what you marked. We marked that segment BE is congruent to segment EC. On this number 2, it says that BD is the altitude. An altitude is a segment in a triangle that connects a vertex of the triangle to its opposite side at a right angle. So as soon as we see the word altitude, we need to mark that right angle because BD is perpendicular to AC. So we put a right angle symbol here, and what we marked is we marked that angle BDC is 90 degrees, or you can say that BD is perpendicular to AC. Now that we know those definitions, we can use them to set up algebraic equations. In number 1, it says that AD is the altitude. So you've got to get in the habit, as soon as you see the vocabulary word, to mark your picture that corresponds with the vocabulary word. So if AD is the altitude, that means that AD is perpendicular, so we're going to mark the right angle here, to BC. And if this right angle mark here is in the same place as the angle that's given, 11x plus 7, that means that 11x plus 7 is equal to 90 degrees. So my first step will be to subtract 7 from both sides, and I'll get 11x equals 83. I'm going to divide by 11 on both sides, and in your calculators, 83 divided by 11 is going to give us a decimal, so we're just going to round to the nearest tenths place. It's going to give us 7.5454 repeating. So we're just going to make that 7.5. And then when we check our work, we're going to substitute the x back in. We're going to take 11 times x, which we said was 7.5, plus 7. And because we rounded, we're going to get approximately 90 degrees. So 11 times 7.5 plus 7 gives us 89.5, which, because we rounded, is pretty close to 90, so we can assume that we did this right. All right, I want you to try number 2 on your own. BD is the median of triangle ABC. So go back up to your definition of a median, and what would you mark on your picture? After you've marked that on your picture, solve for x to find, to figure out that each side is congruent. Okay, if you got x is equal to 1.5, go ahead and move on. If not, stick around and let's see what you did. Alright, so we know that this is the median, so we're going to mark AD congruent to DC. And algebraically, if two segments are congruent, then that means their measures are equal. So algebraically, we set 3x plus 4 equal to 11x minus 8. I'm going to start by adding 8 to both sides of my equation. I'm left with 3x plus 12 equals 11x. Then I'm going to subtract 3x from both sides. So I get 12 equals 11x. Or sorry, 12 equals 8x. And divide by 8 on both sides. And we do get a decimal of 1.5. If I substitute my 1.5 back in to each side of my equation, I do 3 times 1.5 plus 4, and I'm going to get 8.5 for segment AD. And then I do 11 times 1.5 minus 8, and I get 8.5 for DC. Alright, and to add to our list of vocabulary, we're going to learn about points of concurrency. And these points of concurrency that we're going to talk about exist inside of a triangle. A point of concurrency is where 3 or more lines intersect. So remember, 2 lines intersect at a point. If you have 3 or more lines that intersect at a point, that point is called a point of concurrency. The first point of concurrency that exists in a triangle is going to be called the incenter. The incenter is formed when you construct 3 angle bisectors of the triangle. So if I bisect this angle of the triangle, if I bisect this angle of the triangle, if I bisect this angle of the triangle, and extend those angle bisectors, then this point here is called the incenter. It's where my 3 angle bisectors meet inside the triangle. So as soon as you see the word incenter, you're going to mark your angles congruent. So mark this set of angles congruent, mark this set of angles congruent, and mark this set of angles congruent. The next point of concurrency is called the centroid. When you think of centroid, think of the center. When you think of center, think of middle. The centroid is where 3 medians intersect in a triangle. And remember, a median connects a vertex to its opposite side at the opposite side's midpoint. So we have 1 median here, so we know that these sets of segments are congruent. We have 1 median here, so we know that these sets of sides are congruent. And then we have our other median here, so we know that these sets of sides are congruent. Well, that point where the 3 medians meet is called the centroid. So as soon as you see the word centroid, mark where the segment bisectors are, mark those segments congruent to each other. The next point of concurrency is called the circumcenter. The circumcenter is formed by 3 perpendicular bisectors of a triangle. So if I take this side of the triangle and I construct its perpendicular bisector, perpendicular means it meets at a right angle, bisector means it cuts the segment in half. If I construct the perpendicular bisector of this segment, the perpendicular bisector of this segment, and the perpendicular bisector of this segment, where all 3 of those perpendicular bisectors meet here is called the circumcenter. So as soon as you see the word circumcenter, you're going to mark segments congruent, so where the midpoint is, and you're going to mark each of these lines as perpendicular, so your right angle. And then the last point of concurrency is called the orthocenter. The orthocenter is the point of concurrency of three altitudes in a triangle. Remember, an altitude connects a vertex of a triangle to its opposite side at a right angle. So as soon as you see the word orthocenter, there's going to be three spots where you mark right angles, and then where those three lines come together here, that's called your orthocenter. Okay, so now we're going to use our new vocabulary words to set up algebraic equations when we're given figures. It says, number one, that D is the circumcenter. Well, as soon as you see that word, you need to mark the segments in the triangle. Circumcenter is three perpendicular bisectors. So we have bisecting AB here and here. We have bisecting BF here and here. And we have bisecting AC here and here. So we're marking all of those sets of sides congruent. And then we have to mark the perpendicular part of the vocabulary. So that means that DE is perpendicular to AB, DF is perpendicular to BC, and DG is perpendicular to AC. Now that we've marked everything, let's see what we were given. We were given this 37 here, and that has to do with the side lengths. There's no x involved, and there's no angle involved. So we're trying to find x and then the measure of the angle. Well, here they gave us an angle of 8x plus 50. And since perpendicular bisectors form right angles here at DF, we're going to set 8x plus 50 equal to 90 because this is a right angle. I'm going to subtract 50 from both sides, so I get 8x is 40. Divide by 8 on both sides, so I get x is 5. Then it asks us to find the measure of BFD. Well, we could go back, substitute our x into our equation 8x plus 50, or we can just think about it. If this is the circumcenter, that means that this DF is perpendicular to BC. So that means that right away, angle BFD right here is 90 degrees. Okay, go ahead and pause the video and see if you can use your definition for centroid to find the measures or the values of x and z. And you should have gotten x is 2 and z is 3. If that's what you got, go ahead and move on. If not, stick around. Let's see what you did wrong. All right, D is the centroid. That means the point of concurrency of three medians. That means that this BG here bisects, I think that was supposed to be an A, bisects AC at G. So we're going to mark AG congruent to GC. We're going to mark BF congruent to FC. And we're going to mark BE congruent to EA. Now that we see that those sets of segments are congruent, we're going to have to solve for Z separately than when we solve for X. I'm going to start with Z here. Well, since these two segments are congruent, we can set up algebraically that their measures are equal. So 5Z plus 6 equals 7Z. So I'm going to subtract 5Z from both sides of my equation, and I get 6 equals 2Z. I'm going to divide by 2 on both sides of my equation, so I get Z is 3. For my x value, I'm doing the same thing. If these two segments are congruent, then their measures are equal. So 15x plus 7 equals 37. I can subtract 7 from both sides of my equation, so I get 15x equals 30. Divide by 15 on both sides of my equation, so I get x is 2. Okay, number 3, I'd like for you to try on your own as well. It says D is the orthocenter, so use the definition of orthocenter to find the value of x in this triangle. You should have gotten that x is 30. If you found that solution, go ahead and move on to the next problem. Okay, an orthocenter is where three altitudes meet. An altitude connects a vertex to the opposite side of the triangle at a right angle. So that means that BG is perpendicular to AC. And that means that there's a right angle here. So they gave us that right angle has a measure of 2x plus 30 degrees. Well, that 2x plus 30 degrees has to equal 90 degrees. So we set up the equation 2x plus 30 equals 90. I'm going to subtract 30 from both sides, so I get 2x equals 60. Divide by 2 on both sides, and I get x is 30. Okay, go ahead and try number 4 on your own. This time we have the in-center. So as soon as you see in-center, what should you mark on your picture? Then you're going to use that definition to find the value of y. Alright, you should have gotten the solution y equals 3. If you got that, go ahead and move on to your practice. If not, this is how you do it. An in-center, that's where 3 angle bisectors intersect. So this angle is congruent to this angle. Angle NHK is congruent to KHM. And angle LJK is congruent to angle KJM. Well, this right here is how we set up our equation. If these two angles are congruent, because it's been bisected, the angle LJM has been bisected, then that means that 10y is equal to 9y plus 3, because congruent angles have equal measures. So 10y equals 9y plus 3. And this equation is really simple. You just subtract 9y from both sides, so you get y equals 3.